One thing that it's important to note about sample selection is that sample selection does not introduce a bias in our estimate of the relationship between a explanatory variable and an outcome variable if we selected the sample only on the basis of values of the x variable. So we can think about it this way. Suppose we have test score and student-teacher ratio and observations for a variety of districts, as we note here. If we say, well, we're not going to consider observations for school districts that have student-teacher ratios less than some level, so we don't include these, our estimate for the remaining data will be an unbiased estimate of the slope for that level of STR and higher, so it will be unbiased for that. So there's no violation of any of our ordinary least squares condition in that sense, because the error term here is uncorrelated with our student-teacher ratio. We could imagine also likewise another situation where we have a nonlinear relationship, and you might think, oh, but if we have a nonlinear relationship like this, surely if we select the sample according to that threshold, then we're going to completely have a biased estimate of the result. So, you know, if we select one sample, we get a positive slope, and if we get another sample, we get a negative slope, right? So here it would be positive, here it would be negative. But actually, that's not really introducing bias, because our estimate of the coefficient is indeed unbiased for the data that we have. So if we restrict ourselves to only looking to school districts with student-teacher ratios above that level, our slope coefficient is unbiased for that that condition. Conditional on the x's, our slope is an unbiased estimate of the relationship between student-teacher ratio and test score. Likewise, if we choose to have only the small student-teacher ratio classes, we'll estimate this relationship, and that's also going to be an unbiased estimate. So determining the sample based on the x-axis is not going to introduce bias. It is, of course, going to introduce inefficiency in the sense that our sample size is going to be smaller, and if you recall, the standard errors of the estimated coefficients depend on the sample size, and a smaller sample size means a greater standard error of the estimated coefficient. So we'll be less likely to be able to reject hypotheses about the values of the coefficient, because, in other words, the confidence interval of our estimated coefficients will be much larger because the standard errors of our estimated coefficients are larger. So we lose precision in our estimates about what the value is of the estimated coefficient.